Hi. This presentation takes a look at the British Petroleum, or BP, Deepwater Horizon oil spill and the inadequate risk management that led to the catastrophe. This slide is a depiction of the depth of complexity of the deep dig for oil. It conveys the concept of performing the task of oil exploration underwater using mining vehicles at the seafloor. This is clearly not a standard project that has a reference of how to go about working through a multitude of elements that are miles below the sea to extract oil. This project should have been perceived through the eyes and lens of complexity. This picture conveys what will evolve into a dynamic, complex project rather than the planned linear approach that BP embarked upon. This presentation is made from Caitlin Seven, John Sorg, and Sarah Williams for the University of Virginia School of Continuing and Professional Studies Risk Management class. This slide depicts a timeline from the development of the oil rig through the catastrophe and shows that it took until September 19th for the well to be sealed off. As you can see, the explosion happened on April 20th, and there was a search and rescue team on April 22nd and 23rd. It took until April 29th for the government to react, and the president didn't visit the Gulf Coast until May 2nd. It wasn't until May 5th that they finally resorted to a complex response method to deal with the situation. In June, there was a public relations campaign that tried to help cover up and deal with the public outcry, and it wasn't until September 19th that the seal was finally closed off and the oil stopped spilling. As this presentation will show, in the case of BP, their culture didn't work effectively. BP's culture allowed extreme short-sightedness in pursuit of profit at the cost of safety or environmental stewardship. As the drill was planned, BP chose a cheaper casing seal, which reportedly contributed to the blowup. Also, the company intentionally cut corners on quality risk assessment, preparedness, and procedural and safety standards. Investigators found that BP executives ordered partners to cut corners because their ambitious drill schedule was off by several weeks. Hours before the explosion, multiple warnings arose, yet they were all ignored. This is giving a little bit of background to the industry and to BP. A large in-scope comprehensive project risk management program portfolio should plan and execute measured responses to a successful mix of identified, preventable, strategic, and external risks. This approach is particularly applicable within the project and portfolio risk management of the oil and gas industry. The Deepwater Horizon and any subsequent future oil and gas industry catastrophic incidents may be seen as particularly egregious due to the number of similar events which occurred during recent offshore oil and gas operations. This slide lists only a small sampling of the past catastrophic incidents within this particularly dangerous industry. The risks, operating experience, and devastation from these incidents were all well documented and should have not been repeated. Shell Oil developed scenario analysis in the 1960s for 5 to 10-year project planning. Business environment disruption is the #1 economic risk in the energy sector. This technique selects about 4 risk drivers out of the contemporary known macro issues. Strategy devised from plausible scenarios developed by analyzing the identified risk issues. And projects must demonstrate viability against both global and local support-focused scenarios. The Shell Oil Scenario Analysis methodology is focused on the viability of oil and gas industry projects, and it's indicative of the industry's extended time period, project life cycle exposure, and its massive project requirements. It is not clear if this methodology is any better at determining critical risk factors within the safety and reliability protocols of final project deliverables than other similar approaches. The oil and gas industry is involved in complex, long-range, expensive projects. The industry is marked by large-scale, high-risk systems and environmental uncertainties. Longer projects derive greater uncertainties that translate into greater risk and should be seen and taken more seriously. The Deepwater Horizon catastrophe brought enormous scrutiny into the reliability and safety culture of the entire oil and gas industry. The nature of the accident brought enormous worldwide attention to the offshore drilling risks in particular. The sheer enormity, length of time, and logistics required of platform construction projects often creates a disparity within the process capabilities of the final project and subsequent ongoing project maintenance deliverables. This can additionally create inconsistencies and greater risk within the design and operation of the various integrated mechanisms needed to ensure the reliability and safe operation of multifaceted drilling operations. The unprecedented scope and risk environment of projects such as the Deepwater Horizon are not readily supported by more conventional risk management tools. Reliable project risk management program elements such as risk breakdown structures and other widely used project risk checklists are much more difficult to apply where past experience concerning many critical risks is non-existent or otherwise largely unknown. However, BP could have and should have done better. The symptoms and root cause that contributed to the Deepwater Horizon oil spill. There was a compilation of multiple things: approach in risk management, culture of profit over safety, operating outside industry standards, and technical causes, as noted. The conditions that allowed for these symptoms to manifest primarily was a gap in regulation of the industry, and that was the root cause. BP's underground dig for oil was characterized as an accident waiting to happen. An investigation by Fortune magazine revealed a safety philosophy that focused too much on spilled coffee and not enough on drilling disasters. BP had strict guidelines that employees must put a lid on a cup of coffee, but as it became apparent, the necessary effort to ensure guidelines were in place to contain the oil had apparently not received comparable level of effort. They had no standard procedure for how to conduct a negative pressure test, a critical last step in avoiding a well blowout. If done properly, that test might have saved the Deepwater Horizon. The BP organizational culture failed their organization and the world's environment. BP can be defined as a risk-seeking organization because they tolerated a high amount of known risk in a gamble for maximum profits, which led them to take dangerous shortcuts, not take proactive actions, and focus their risk assessment on probability, which neglected the impact of a disaster. Quality was sacrificed for cost and schedule. They should have built a relief well, but they didn't want to invest the $100 million. This was very irresponsible. They could have paid for other safety mechanisms, but since they were not regulatory requirements, they were seen as optional and too costly, which is incredibly irresponsible again. Deepwater project risk planning was seen as focusing on risk mitigation tool provisions, which were geared towards operational personnel. This operation-centric focus shifted proactive and necessary risk reduction and mitigation capabilities away from project deliverable risk prevention and response mechanisms. Reliance upon risk mitigation within the operation setting contributed to the development of a control room status and alarm indicator overload scenario. These indicators and alarms provide rig operators with the information they need to control and mitigate ongoing operational risks. The misappropriated scope and integration requirements of this particular risk management scheme created a situation whereby certain indicators and alarms could be misread, improperly prioritized, or even missed altogether by even the most experienced operators. Without a robust risk mitigation toolkit, such as a pre-operational relief well, which many people suggested but BP decided to ignore, the rig operators did not even have the necessary apparatus to mitigate all of the critical risks enunciated by the operation status and alarm indicators. An improved and responsible risk register, which would have included triggers, probability, impact, and response, could have saved many lives and much devastation. According to the Center for Biological Diversity in 2011, in total, the oil spill had likely harmed or killed approximately 82,000 birds of 102 species, approximately 6,165 sea turtles, and up to 25,900 marine mammals, including bottlenose dolphins, spinner dolphins, melonhead whales, and sperm whales. The cause and effect model for risk should have included triggers, probability, impact, and response. As the National Commission on the BP Deepwater Horizon spill and offshore drilling reported in 2011, quote, each of the mistakes on the rig and onshore by industry and government increased the risk of a well blowout. The cumulative risk that was resulted from these decisions and actions was both unreasonably large and avoidable. BP, the oil industry, and the U.S. government were inadequately and irresponsibly prepared for the complexity of this project. There was a lack of understanding for the magnitude of possible risks and a failure to include and value perspectives from important experts. The United States government, oil industry, and BP learned that they need to work together to create more rigid and more sufficient regulations and risk management plans that include identifying proper triggers. BP should have put all hands on deck to respond instead of approaching the crisis with ease. They could have always retracted their response instead of going days of being under-responsive. If you think about a fire breaking out, all the firemen and all the fire trucks that are nearby go immediately to the fire, even if it's just an alarm. But they come prepared. BP should have put all hands on deck and come prepared and then withdrawn any excessive responses. Since the spill, the industry has strengthened their relationships in the industry, government, and responders, and there's an identified network of experienced experts from around the world, which is constantly updated. A more complete and capable list of supplier and vendors with precise capabilities is also updated frequently. The scope of projects like this inhibits comprehensive regulation. Government can be unable to regulate the full scope and technical aspects of complex projects because of a lack of resources and other factors. The regulator's lack of understanding of technology was problematic. However, the government retains responsibility for inspecting and verifying industry's self-monitoring processes. Therefore, the government and industry need to work together in a more cooperative way to ensure safety for all. Certain emergency management program requirements, which are universally applied within high-risk environments such as the Deepwater Horizon, were apparently not delivered by this project. A culture of emergency risk planning, mitigation, execution, maintenance, and response must be strictly enforced in order to adequately respond to potential catastrophic consequences. Post-accident identification of organizational project management weaknesses revealed a top-down culture that ignored or did not otherwise identify numerous critical risks regarding the reliable and safe operation of Deepwater Horizon. The potential risk regarding the circumstances of the accident, its mitigation alternatives, the catastrophic aftermath, and the emergency response were not at all beyond what would be identified within even the most rudimentary risk planning frameworks. Perhaps the only explanation for this oversight was that BP had a desire for increasing profit margins, which overshadowed the need for an abundance of caution and robust project risk management structure. However, BP presumably did not consider the additional secondary risk of confidence, reputation, and loss. This slide reiterates the lessons learned in the risk response time. The catastrophic risk response time driven by organizational culture and shareholder profit over safety concerns. BP's reaction to the disaster is seen by many to have become more about BP's public relations than the public's right to know. Instead of releasing credible figures of the volume of oil flowing into the environment, BP knowingly cited a very conservative estimate. They initially put up a video loop instead of a live feed. Even though they knew that and saw the consequences Their website excluded information about damages to fish and wildlife for too long. It took until May 5th, 2010, for BP to respond with a complex response method. Many wondered if it would have taken even longer if not for the public outrage. In investigating the disaster, the Alternative Response Technology team screened more than 120,000 ideas for new containment and response technologies, techniques, and approaches from individuals and experts around the world. This obviously should have been part of the plan from the beginning. There was lots of lessons learned as they investigated the causes of this oil spill and looked into ways to make sure that it doesn't happen again. There have been new and strengthened collaborative relationships, advanced processes, systems, protocols, procedures, and organizational capabilities. And a lot of those came from another valuable information component of the overall response, which was a rapid scale up in scientific capability. For the Deepwater Horizon spill, the response team pulled together experts from disciplines such as geochemistry, industrial hygiene, water sampling, air sampling, reservoir monitoring, ecology, environmental science, hydrogeology, flow assurance, process safety, toxicology, zoology, ornithology, and geophysics. This wide net provided the intellectual edge needed for effective response and should have been part of the planning and risk management from the get-go. BP's culture was reactive and cost-focused, which is short-sighted and caused them to be ill-prepared. Greed allowed them to neglect proven risk management processes, and we all paid the high price. BP would have saved billions of dollars if they had conformed to proper processes and prepared for the known risks instead of gambling for profit. Their gamble cost them, and it cost all of us. A thorough cause and effect diagram would have illustrated the possible devastation and indicated triggers. The fact-finding National Commission on the BP Deepwater Horizon spill and offshore drilling convened soon after the incident. The accident investigation provided by the Commission identified numerous problems with the safety and reliability culture of the companies involved. As one solution, the Commission recommended that the oil and gas industry employ a comprehensive and fully independent industry self-regulation oversight mechanism. This proposed industry oversight organization would ensure such programmatic requirements as the timely sharing of operational experience, the universal maintenance of critical risk management standards, and the highest possible quality and consistency within the application of cutting-edge technology. The Commission report revealed that it perceives the current American Petroleum Institute as primarily an industry advocate organization which does not exemplify a valid comprehensive industry self-regulation oversight program. The unprecedented nature of the Deepwater Horizon project unquestionably required unprecedented risk management protocols. The bottom line safety culture of the companies that partnered on the development, construction, and operation of the Deepwater Horizon project was apparently so broken that risk mitigation approaches evident within much less risky environments were not provided. As a result, risk mitigation efforts were not adequately employed until catastrophic damage already manifested itself.